Can you see this? Okay, perfect. As Francesca said, my name is Rebecca Popowsky. I'm a research associate at Olin Labs, and I teach at University of Pennsylvania. My presentation today is focused on Project Near Research in Practice, and I'm calling it the third site. I just want to acknowledge, first off, that it's a bit of a crazy time to be speaking from the US to an international audience. This is the spread that we saw in the New York Times yesterday. So we're aware that the entire world is watching what's unfolding right now in Washington, D.C. So it's a bit of a difficult time to talk about our work. But I also think that it's a time where we're actually, sorry. Sorry about that. We're actually, even more resolved than ever in the type of work that we're doing and the importance of working on behalf of communities and of the environment in landscape architecture and urban design. So before I jump into the primary case study for today, which is soilless soils, I just want to give a little bit of context. So I am a landscape architect at Olin. Olin is a landscape architecture and urban design firm with offices in Philadelphia and Los Angeles. So some of the projects that are currently on display in the exhibit are Pier 26 and the Los Angeles River Master Plan. So these two projects, I think, represent extraordinary examples of transitional landscapes from a certain perspective. They're both projects that are in, big urban centers, and that actually represent a transition of post-industrial infrastructural landscapes into landscapes that will be amenities for communities and will have environmental and ecological benefit. So both of those projects, I hope that everybody will get a chance to review in the digital exhibition. But the work that I'm actually going to focus on today is a little bit different. It's a type of transitional landscape that is actually looking not so much at the big projects that we have in the centers of the urban context, but it's actually looking at the impacts that some of those projects have on areas that are in the peri-urban or peripheral landscapes, and specifically in landscapes of extraction and of waste, as Francesca said. So in terms of, just to give some context about Olin Labs, Olin Labs is a community of practice and the research and development group within the Olin studio. The community of practice is made up of Olin landscape architects and designers. It's not a separate group of researchers that work outside of our typical design staff, but it's actually a framework for landscape architects in our practice to engage in primary research, development, and education. So the Soilless Soils project is the one that I'm going to focus on today. The basic research goal of this project, and I'll talk more about it, is to think about recycled glass fines as a replacement for sand in green infrastructure soils. So in order to frame where this kind of question and research initiative came from, I'm going to start with this quote from Carol Burns and Andrea Kahn from their compendium Site Matters. So Burns and Kahn state that in design discourse, a site too often is taken as a straightforward entity contained by boundaries that delimit it from the surroundings as a circumscribed physical area given a priori. Any place registers tangible certain aspects of many larger, more spatially extensive patterns, orders, and systems. Each built project creates new forces within its own area and also modifies and influences systems that both reach beyond the site and operate within it. They go on to say that conceived over time this way, the site has three distinct areas. The first, most obvious one is the area of control, easy to trace in property lines. The second, encompassing forces that act upon a plot without being confined to it, can be called the area of influence. And third is the area of effect, the domains impacted following design action. Lying outside of direct design control, the areas of influence and effect situate design actions in relation to wider processes, including the often unpredictable change propelled by design intervention. All three areas exist squarely within the domain of design concerns. And so, as landscape architects, when we think about the ways in which we can actually have agency in these sites of extraction, sites of waste, the sites that are impacted directly in very real ways by our project work, but that are outside of the project boundaries, we have to sort of start to look beyond the drawings, beyond the boundary lines, beyond the sight lines. And so if we think about this image as a site plan showing the bounded site, which is our kind of primary focus as designers typically, we can start to think about other tools in our toolbox, such as project specifications, material analysis, material specification, and supply chain, et cetera, as ways, and life cycle thinking as ways to expand our idea of site and actually to intervene beyond the boundaries of the site. And so in the example of soilless soils, this is really where we began our investigation. This was an example of a project that started as project near research, meaning project that research that's coming directly out of and is supporting a project in the office. And really the starting point of the entire initiative was where you see here the red box, highlighting a paragraph in a specific project, in a project specification. So this is a 19-page soil specification from a project at the University of Washington. And this inquiry into soils started when the project team came to Olin Labs and asked whether it was possible to simply change 6 words in a soil specification of 19 pages and to replace and to add the language that sand material or finely ground recycled glass cullet could be used for planting under drainage and as a mixed component for manufactured soil. So with that question in mind, we set ourselves up to look at really the challenges that could be addressed through this question. And what we found is that the question of recycled glass and sand were actually, incredibly urgent, touched on some incredibly urgent issues actually environmentally. And so, as many of you will know, sand and gravel comprise the most heavily extracted material group on the planet, even ahead of fossil fuels and biomass. And that there are shortages of sand in many regions of the world. At the same time, glass recycling is very problematic in the US and elsewhere. It's very difficult and expensive to recycle glass. And so many municipalities, after changes in international markets for recyclables in the past 2 or 3 years, many municipalities are actually just sending glass, huge amounts of glass, to landfills. And then finally, we're also addressing kind of challenges around green infrastructure and manufactured soils in the urban context. And so as landscape architects and urban designers, we're constantly challenged with building effective soil profiles in cities without damaging or borrowing too much natural soil from sensitive areas outside of the city. And so the research question that was kind of finalize out of that initial investigation is this one. Is recycled glass a viable alternative to natural sand as the inorganic component of manufactured green infrastructure topsoil blends? And so the way that Olin Labs takes on that question initially is through a literature review. What we found is that there's a lot of research that is adjacent to this topic, in the sense that there's a lot of proof of the use of glass sand and glass cullet in the landscape in other applications that are not quite the same as green infrastructure topsoils. So, for example, glass has been proven effective as an artificial dune replacement. In this study, the artificial sand that was used as for artificial dunes actually worked slightly more effectively than the natural sand in growing these dune grass species. We also saw a lot of studies that were focused more on civil engineering applications. So, for example, glass sand being used as a drainage material that functioned as well as natural sand, as pipe backfill, as road embedment, and subgrade material. And we found that that local agencies had also already were also already specifying glass cullet in road construction. In terms of the environmental comparison of recycled glass fines and aggregate, we did find some international examples of studies that showed that the use of recycled glass was preferable to natural aggregate, but we did not find any life cycle assessments that were published in the US showing this type of comparison. And so at that point, what we established was that there was a gap in the research in terms of US-based life cycle assessment, but also in terms of proving that glass fines would be a suitable alternative to natural sand, specifically in topsoils, so that it would be able to support plant growth safely in green infrastructure applications. And so that's when we started our first collaboration with an academic institution. We worked with a student at the University of Pennsylvania, Anqi Zhang, to complete an initial life cycle assessment, locally based, which showed that that there actually were savings associated with the substitution of natural sand with glass fines. We found that it could represent up to a 67% reduction in greenhouse gas emissions compared to natural sand. We also began early on to look at the implications that this type of substitution would have in terms of material sourcing and in terms of waste management in the city. So we looked at, what was, in terms of glass cullet and glass sand, what would be available in the current marketplace, and whether there actually was a feasible, economically feasible way of replacing sand with glass in public works. After that initial kind of secondary research work, we were able to put together a team, a hybrid team, partnering with Temple University and the Ian McHarg Center at Penn Design, along with Tim Kroll, a soil scientist. And we were lucky enough to receive funding from the William Penn Foundation to take our study deeper into primary laboratory and experimental analysis. So our initial experimentation actually happened in a small pilot greenhouse study. This was sort of a proof of concept level study, which looked over the course of 12 weeks at 144 plants of 3 different species, comparing different soil mixes that were made up of natural sand, glass sand, and 20% of natural soil. The plant performance over time was measured through leaf chlorophyll throughout the experiment, and also plant biomass at the end of the experiment. So after 18 weeks, we were able to harvest the plants, and what we found was that in the glass sand mix, none of the three taxa of plants exhibited statistically significant reductions in biomass. Um, there was some reduction in biomass of one of the species with one of the pH buffers that we had added was ferrous sulfate addition. But the outcome did tell us essentially that the plants were able to grow in the glass fines as well as in the natural sand. But the primary concern that came out of this initial study was that we did find the pH level of the glass fines to be too high compared to natural sand. So in our next phase, which is ongoing, we've been working with pH mitigation strategies, which include primarily just changing the type of compost that we're using in the mixes. We initially used mushroom compost, and by shifting to more typical yard waste compost, we've been able to bring the pH down. And we've also found that by shifting from more finer grain sand to more coarse grain sand, that also has a big impact on the pH level. And so after this pH mitigation, where we stand now is that the pH levels seem to be at tolerable levels at this point, and that nutrient availability and cation exchange need further evaluation. Although present sodium and aluminum and zinc do not seem like they will be an issue. Alongside this study, we are doing some secondary studies that look at leachate, rapid leachate, and microplastics. As you saw in the earlier image, the material that we're using, the crushed glass that we're sourcing from recycling centers, does have a fair amount of mixed waste debris, and so it's important for us to understand, in addition to the glass itself, whether there are any contaminants that would impact our ability to use the material safely. So where we are right now is that we're in the process of running a 6-month mesocosm study, which allows us to build these columns of soil profiles, which really mimic the way that a green infrastructure soil would work in situ, in order to look at the flow of water, the impacts on leachate, and things like pH. And then finally, alongside that mesocosm study, we're also running a more in-depth feasibility study. And I think that this is one of the more important aspects of the study in the context of this symposium, which is that we're really trying to work closely with public agencies here in the city of Philadelphia and elsewhere to understand what the impacts of this type of material change could have in terms of urban systems. And so we're really looking at the economic picture. We realize that in order for cities to be able to reasonably make this type of switch from a natural material to a recycled material, it's absolutely critical that the recycled material, is not more costly, and actually hopefully represents cost savings to cities. And what we found in our initial analysis is that cities like Philadelphia, if they're able to divert their glass waste stream from landfills, they would not only be able to make this economically feasible, but the reuse of recycled glass in their own public works would represent very significant cost savings to the city. Over time, the cost of landfilling materials in cities like Philadelphia is skyrocketing. And at the same time, the price of natural materials such as sand and gravel is also going up. And so we feel pretty confident that that more and more over time cities will see the value really in starting to try to close these waste loops and use their own waste materials in their public works and construction. So I'd like to talk a little bit about some of the lessons as landscape architects that we've pulled out of this type of practice-based research. One thing that we found in doing this type of work, this collaborative work with universities and public agencies at Olin Labs, is that as designers, we actually are very well situated to pull this type of hybrid collaboration together. For example, when you're talking about building teams for grant-based work like this, the process is actually very similar to the types of RFPs, pulling together collaborative teams for RFPs the way that we do in all of our work. Building coalitions and bringing together experts to take on some of these complex problems is something that I believe that landscape architects and urban designers are exceptionally well placed to do. Practice-based research also, I think, can really capitalize on some of the other things that we know and that we're good at as practitioners, as designers. The bridge between practice and the academy is something that I think we all acknowledge as being ever more significant and urgent. The cross-disciplinary perspective that this type of research brings really allows us to look at many scales at once, as you've seen, from the very small scale and in the laboratory and material details up to urban systems and regional waste streams and material supply chains. The direct feed between research and project work, I think, is also significant. The fact that as researchers in practice, we have the ability to directly put what we learn into practice in projects that are in every stage from concept design through construction is also a significant, in terms of the speed at which change really needs to happen in many of these projects. And then, of course, just the fact that the research, the applied research, is feeding into real world action. This slide is simply meant to kind of emphasize some of those points. The image on the left is just a snapshot of current projects that would be ongoing at any particular moment in our office, as an example. And then the slide, the image on the right, is showing that the staff members in our office who are currently engaged in some kind of research. And so, in my mind, at least, these two images really emphasize the power, I think, of having research ongoing that is embedded in project work and that is actually being run and sort of owned by the landscape architects that are doing the work. Finally, I think that one of the other things that we've learned from this project and that we hope to build on is the fact that we're in a great position to build collaborations and really work in solidarity with lots of folks in different places geographically and also in different roles, from private, public agencies to academia. And so this slide is just an example of how the initial core research team that I described of Olin, with our academic partners and the support of our locally based public agencies, has started to grow significantly over the past year. And there are new collaborations that are underway in multiple cities in the US, Hoboken, Tucson, Baltimore, Maryland, and also additional research that we're working through with the US Forest Service building on this initial study to include more research into plant performance in the urban environment. And finally, we're seeing this as an opportunity, I would say, to advocate really for change in cities, and for kind of a more holistic way of examining the relationships between urban design and the landscapes that we impact intentionally or unintentionally when we make decisions about materials and about waste. So I'll end there, and I'm more than happy to discuss further or to answer any questions that you might have.